Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We've reached the end of our equations unit, and today we're going to put everything we've learned together. Solving equations, like terms, the distributive property, you name it, and we're going to solve multi-step equations. To solve multi-step equations, you should do the following things. You should simplify all the parentheses first. So if you have parentheses, you should simplify those first. You should simplify all the like terms in the equations, group those all up, and then whatever is left, solve that equation using your idea of equality. Let's take a look at what I mean here. We'll start off with some simpler examples and gradually get to some more challenging ones. In the ones we do today, we won't bother doing checks just to save a bit of time. So number one, you have x divided by 4 minus 1 equals 20 minus 5. Well, there's no parentheses to solve in this one, but I would group up the like terms first. We have a set of like terms here to group up. So what I would do first is I would rewrite this as x divided by 4 minus 1 equals 20 minus 5 is 15. And then what you have there is a two-step equation that has division and subtraction in it, and you would solve it as you typically would. Add 1 to both sides, and you get x divided by 4 equals 16. And then multiply both sides by 4. Times by 4, times by 4. And this is equal to 1x equals 16 times 4 is 64, or x equals 64. And that is how we begin solving a multi-step equation. You just have to group up your like terms, simplify all the things that you do before solving the equation. Let's look at another example. So we've got an example here. 2x plus 2x minus 8 equals 12 plus 12. Looks really complicated. But what we need to do is solve any parentheses first and group up any like terms first. Well, we've got a bunch of like terms. We've got 2x and 2x. That makes 4x minus 8. And on the other side of the equal sign, we have 12 plus 12 is 24. And once you group up those like terms, you have a basic two-step equation. Now you would use reverse BEDMAS. You would add 8 to both sides. And you get 4x equals 32. And you would divide both sides by 4. And you get 1x equals 8, or x equals 8. So equations that look complicated at first actually aren't that bad once you group up those like terms and simplify them. Okay, same thing here. Check this out. Now we've got 4y minus 6y minus 2 equals 8 plus 2. Well, on this side of the equal sign, I have a like terms 4y and negative 6y. Remember, the sign in front of the term goes with the term. Well, that makes negative 2y. I'll make my y a little better. And I still have minus 2. And on the other side of the equal sign, I have the like terms 8 plus 2 is 10. Now, once again, I have a two-step equation. I'll add 2 to both sides. This will go away, and I'll have negative 2y equals 12. Divide both sides by negative 2. And you get negative 2 divided by negative 2 is 1y equals negative 6, or y equals negative 6. Look at that. You just group up some like terms, and all of a sudden you have an equation that should look pretty familiar to you. Let's keep on trucking ahead, do some different examples. Now this one, I have some parentheses I have to deal with first. So I would group up like terms and do parentheses. So this one, I would distribute the 2 to the x and the 2 to the positive 1. And we would use the distributive property to make that 2x plus 2. And on the other side of the equal sign, I have a couple of like terms, negative 2, negative 2. That makes negative 4. And then once again, I have a two-step equation. I can solve it by subtracting 2 from both sides. And I get 2x equals negative 6. I can divide both sides by 2. And I get 1x equals negative 3, or x equals -3. And there you go. You've got the equation solved. It's just a matter of simplifying, taking care of your parentheses, taking care of your like terms first. Okay, now check this out. This is something that's a little bit different. We have 4m minus 6 equals 2m plus 4. Now this time we have a variable on both sides of the equal sign. We've never had that before. But check out what we do. This is where the whole idea of equality can make things so much simpler. Whatever you do to one side of an equal sign can do to the other. I don't like having the variable on both sides of the equal sign. So what I'm going to do, I like to take the smaller variable. Because if I take the smaller variable, you'll see what will happen here. It's going to leave me with positive numbers. So I'm going to take the smaller variable, this one has 2m, and I'm going to subtract 2m away. Now if I do it to that side of the equal sign, that's fine, just as long as I do it over here. I'm going to subtract 2m over here. Now watch what I get. This becomes 2m. 4m minus 2m is 2m. I still have minus 6. I have an equal sign. This goes away, and now I just have the plus 4 or 4. And now, once again, by using that idea of equality, doing the same thing to both sides of the equal sign, I have a two-step equation. And I can finish solving it by doing add 6. I get 2m equals 10. And then I divide by 2, and I get 1m equals 5, or m equals 5. So if you remember way back at the beginning when people would say, why do I have to do that same thing to both sides? I can just get the answer mentally. Well, now, using that idea of equality, you might not be able to get this by mental math, but using this idea of equality, we can simplify equations so quickly. Let's look at another one. 4t minus t equals 6 plus t. Well, remember, if there's no number in front of the variable, there's 1 there. There's a 1 in front of those. Now let's group up our like terms. First, on this side of the equal sign, I have 4t minus 1t is 3t equals 6 plus 1t. Now I don't like having a variable on both sides of the equal sign. So I'm going to go to my smaller one. This one is 1t, and I'm simply going to subtract it away, which is fine, just as long as I do the same thing over here, subtract 1t. Now watch what happens. 3t minus 1t is 2t. Ha! That one's a smelly one, right? It's 2t. It's very tooty. So 3t minus 1t is 2t. Over here I have 6, and 1t minus 1t goes away. And now look what I have. I have a basic one-step equation that's 2 multiplied by t equals 6. Well, I'm going to divide by 2, and I get 1t equals 3, or just t equals 3. That idea of equality on both sides of the equal sign is so important because it makes solving equations so simple. All I had to do here was take 1t away from both sides, and all of a sudden I had a very simple equation to solve. Let's look at another one that follows that idea. This one, 3w plus 5 equals 2w plus 7. It's once again, I have a variable on both sides of the equal sign. So I like to take the smaller one. The smaller one is 2w. And I'm going to subtract 2w to both sides of the equal sign. Why will I do that? Well, look what happens. 3w minus 2w is 1w. I still have a plus 5 equals 2w minus 2w goes away, and I'm left with positive 7. Now we might know this better as just w plus 5 equals 7. By doing that one step, I'm left with a basic one-step equation where I can subtract 5, and I get w equals 2. That idea of equality is so powerful, and I hope you're seeing that now when you get these more complicated equations that can be made super easy by doing one simple step. It's like Special Agent Oso. One special step, that's all it takes. One special step. Anyway, I think his was 3 special steps. Okay, let's look at another one. 2z plus 4 equals 5z minus 8. Well, I don't like these ones where I use z as a variable. That's a poor choice on my part because z's look like 2's. But what I would do, since I have a variable on both sides of the equal sign, I would take the smaller one and just do minus 2z. And then do minus 2z on the other side. And here's what I'm left with. This goes away, and I'm left with 4, positive 4, equals 5z minus 2z is 3z, minus 8. And now I have a 2-step equation. The variable's on this side. I add 8 to both sides, and I get 12 equals 3z. And then it's multiply by 3, so I divide both sides by 3, and I get 4 equals 1z, or 4 equals z. That idea of equality is so powerful. Okay, let's look at this now. Now we've got the whole Megillah here. We've got parentheses, we've got like terms, and we've got a variable on both sides of the equal sign. But start off first, deal with your parentheses. So 5 multiplied by y is 5y. 5 multiplied by negative 3 is negative 15. Equals, let's think of y as 1y plus 1. Now, what I would do now is I usually like to take the smaller one, so 1y, and I'm going to subtract 1y away from both sides. Going to be left with 4y minus 15 equals, this goes away, positive 1. And now I have a 2-step equation I can solve. Do plus 15, and I'm left with 4y equals 16. And then do divide by 4, divide by 4. 4 divided by 4 is 1y equals 16 divided by 4 is 4, or just y equals 4. We're doing some pretty awesome stuff, but if you've been using all your skills previously, then you're just building on one new step. Let's check this out. 6 plus 4 times r minus 2 equals r plus 7. Weeks ago, we would have thought this was so complicated, but we can do this. Okay, let's work through our parentheses. 6 plus 4 times r is 4r, and 4 times negative 2 is negative 8, equals r plus 7. Let's combine our like terms. Positive 6 and negative 8 make negative 2. So let's call this 4r minus 2 equals r plus 7. Now we still have these r's on both sides. Think of this as 1r, and let's take away the smaller one, minus 1r, minus 1r. And I'm left with 3r minus 2 equals, this goes away, 7. And now I'm left with a 2-step equation. Plus 2, plus 2. And I'm left with 3r equals 9. Divide by 3, divide by 3. And I'm left with 1r equals 3, or r equals 3. Look at that. It's all the skills we've been using, all the skills put together. Just work through it sequentially like that. You can do it. I hope that helps with your assignment today. That's all for now. Flexing Teacher Weber, out.